Hello everyone, so today we're gonna finish what we've done last time. So we have four more examples in the exercise set. So given the function fx s x squared plus 8x plus s has equal roots, find the value of the positive constants. So constant s, so we know that we have equal roots when delta is equal to 0. So let's find what delta is equal to. So delta is b squared minus 4ac, which is 8 squared, because b is 8, 4ac, so a is s, and c is s. So it's 8 squared, which is 64 minus 4s squared. And the case where it's equal roots, that is true when delta is equal to 0. So fx has equal roots when delta is equal to 0, right? So 64 minus 4s squared equal to 0. 64 equal 4 squared, s squared. 64 over 4 is 16, equals 16. Then s is equal plus or minus 4. But because they specified it to be a positive value, then s is 4. And we wouldn't consider minus 4 as our answer because there is a condition there in the question. And find the range of values of k for which 3x squared minus 4x plus k equals 0 has no real solutions. So first of all, as usual, we find fx equal, we need to find delta, which is b squared minus 4ac minus 4 squared minus 4. A is 3, c is k, and that is equal to 16 minus 12k. That is perfect. So fx has no real solutions when delta is less than 0. Okay, so let's apply this. 16 minus 12k less than 0. So I'm gonna solve this inequality. 16 less than 12k. So that's k more than 16 over 12. 16 is 4 times 4. 12 is 4 over 3. K. Or more like k more than 4 over 3. So this is the range of values of k for which this quadratic equation here has no real solutions. See, it's very simple. Once you know when it has like no real solutions, it's for delta is less than 0. When there's one repeated or one solution is when it's equal to 0, and there's two distinct solution, it's when it's more than 0. So let's do two more questions and we'll be done for today. So the function gx x squared plus 3px plus 14p minus 3, where p is an integer, has two equal roots. So we need to find the value of p. So we need to find, first of all, the value of p, and then for that value, we need to solve the equation. So p, we're gonna find delta first and equal it to 0 because we're looking where it has two equal roots. So delta is b squared, in this case is 3p to the power of 2 minus 4ac. A is 1, c is 14p minus 3 equal to 0. So simplifying this one is 9p squared minus 28p plus 12 equals 0. Actually, this is minus 56p. So here we have a quadratic equation. So in order to find p, we need to solve for p. Because I don't have much space, so I'm gonna write here. So p is using the quadratic formula. We're gonna find this. So like 56 plus or minus. So b is minus 56 minus b plus or minus b squared minus 4ac. So in this case, my b squared is minus 56 squared minus 4 times 9 times 12. So everything inside here will be equal to, I think, 2704 over 2 times 9. Okay. So p is 56. So the square root of this value, okay, is gonna be 52 over 18. So 50, in the case we use 56 plus 52 over 18, I think we get in 108, is it? 108 over 18, and it's gonna give you 6. And in your case, you do 56 minus 52, it gives you 4 over 18, which if you were to simplify, I think gives you 2 over 9. However, the question has specified that p is an integer, thus we only consider in this solution, so p is then equal to 6. So this one is not a valid solution because we know that p is an integer. So we go to part B. So part B, let me just highlight these. So part B, it says for this value of p, solve the equation. So the equation becomes x squared plus 18x, because 3 times p, and then 14 times 6 would be 84 minus 3, so plus 81 equals 0. So we need to find, so I'm gonna solve this one using, you can use either the quadratic formula or factorization. I want to use factorization, I feel like it. So we go into find two numbers that when you add them together it gives you 18. So in this case b is 18, ac is 81, and when you multiply them together it gives you 81. So I can think of 9. So 9 plus 9 is 18, and 9 times 9 is 81. So x, this can be factorized x plus 9 and x plus 9. So as you can see, indeed we found two equal roots. Okay, so this is x plus 9 squared equal 0. So x plus 9 equal to 0. That's x equal to minus 9. Thus, the solution is x equal to minus 9. Anyways, so you can see like we've used the quadratic, what's that? We solved the quadratic equation here and again here. But yeah, this is why it is double quadratic. So for question 7, we have this quadratic equation, and where k is a real constant, and we need to find the discriminant of hx in terms of k. So let's find a discriminant as per what we know. So it's b squared minus 4ac. So b squared is k plus 4 squared minus 4 to ac. So okay. So let me expand this one, so it's at k squared plus 8k plus 16. So you know this one is one of the identities, so it's easy to expand it. So k squared, and this is 4 squared, and then in the middle 2 times k times 4 minus 8k, and I'm ending up with k squared plus 16. Moving on to part B. Hence or otherwise, prove that hx has two distinct roots for all values of k. So again, when we see that the term hence is being used, that means we have to use part A. So from part A, we know that the delta is k squared plus 16. Okay, and this discriminant, I mean k squared is positive because it's a square, plus 16 is a square, so everything as a whole, it's strictly positive. So it always will be positive, but not only that, it wouldn't be even equal to 0 because it's k squared plus 16. So this one is always positive, so is the sum. That means, I mean, from the rule, when delta is strictly positive, then hx has distinct solutions or real roots for all k. So yeah, this is just me writing it, sloppy way. But yeah. So yeah, this sums up the today's session. I shall see you in the next one. Bye.